Hello everyone, welcome to this session talk about the project journey, understanding data in new ways. My name is Alan Lee, Solution Architect from Office of CTO TIBCO. Before we start, let's recap what we talked in last session. We talked about the rise of the data and its evolution. As a result, data structures are no longer consistent and information is related, dynamic, and constantly evolving. That's why the traditional ways are not good enough to model, store, process, and analyze highly connected data. Hence, we came up with some new requirements based on the characteristics of the connected data. We needed more flexible ways to answer questions with dynamic data structures to cope with the rapid changing business requirement. We want to detect and identify complex patterns from highly connected but distributed data. Also, data and events can be processed as soon as they are generated, and machine learning and artificial intelligence can be applied while preserving data privacy and confidentiality. Last but not least, complex data relationships can be stored and queried with constant performance. In this session, we will take a closer look at project journey, which is one of the TIBCO Labs innovation projects. TIBCO Labs project journey helps to solve the critical business problems by providing real-time AI ML-driven solutions based on the data relationships, built on the TIBCO Connected Intelligence platform and powered by innovative data, integrations, and analytics capabilities. Project Journey allows organizations to seamlessly work with graphs of data in a single application that supports any type of vertical use case, whether for creating highly personalized real-time customer experience, checking data across supply chain, or discovering hidden data dependencies. Its cloud-native, open, and AI-driven design make it easy to be extended to provide a fast start template for creating your own applications. With the provided capabilities, Project Journey can track all the events we want for detecting behaviors and hidden patterns. We can also ask questions and get the instant result without waiting for report generation, such as which customer is going to churn, recommend an offer for those customers to post a negative feedback on social media lately for the product, which is the fastest route to get to the point B from the point A, etc. And one of the most important features is to understand the complex data relationships represented by the graph. For example, the interactions between customers and partners. Through the interactions with the graph, we can traverse and explore the graph to discover hidden patterns and the corresponding details. And finally, all the corresponding notifications and actions of detect patterns can be automated. As we see in this high-level architecture diagram, Project Journey leverages TIBCO Graph Database to store the data. We communicate with TIBCO Cloud Messaging and Open APIs. TIBCO Cloud integrations manage the real-time integrations and automation with TIBCO Cloud events. And analytics, visualization, and machine learning is seamlessly carried out with TIBCO Spotfire and TIBCO Spotfire mobs. All core services are implemented as microservices in a loose-coupled way, and Angular-based user interfaces integrated with core services seamlessly through REST APIs. And such, you can customize or extend the capability easily. Since events and data are being modeled and stored in Graph Database, we can query the relationships and traverse the graph using native REST APIs provided by the Graph Database. Check that the installed procedures are supported by the TIBCO graph database natively. We can have notification upon the changes of graph. For example, push and over notifications upon changes of the relationship between data points. The whole things can be deployed on premises, on cloud, or hybrid alongside with TIBCO Connected Intelligence Cloud. And now, let's take a look at how project journey fits into the real world. We take a use case of highly personalized customer experience as an example. In a modern retail environment such as retail bank, we pretty much want to capture and understand every single activities of customers, and then we can analyze the customer behaviors and patterns, such as what kind of product they like or dislike, what touch point they prefer, and etc. The most important, you pretty much also want to understand the relationship and similarity of customers, and such you can make a precise best offer. For example, a time-limited insurance offer. To have a better engagement with your customers and improve the conversion funnel of the buying process. It means on one hand, improve the customer experience, and on the other hand, improve your return on investment. Besides, you can also ask questions and get answers by asking something like, who liked the top-rated product, but eventually purchased a relatively low-rated product referred by his or her friend. Let's see how project journey works to achieve this goal. Here shows how project journey capture the information and how to make a recommendation. First of all, customers usually will leave their feedbacks or comments through different touch points such as social media or websites after making a purchase. All these comments and events can be connected and analyzed using sentiment analysis to extract the relationship and information between customers and products. And then all these relationships will be stored in graph database. This best action will be triggered after customer purchase. In the meantime, if some customers visit the digital channels such as a mobile app, this best offer will be suggested to them as well. Whenever the relationship between the customers and product are changed, the recommendation will change accordingly in real time. This screenshot of project journey gives you an idea about the sentiment analysis result. All comments are analyzed and sentiment result will be stored in the graph database. And it also gives you a holistic view of particular products as well as the sentiment trend of products. Besides, all events such as purchase events will be captured and tracked. All this information will also be stored in the graph database, and such we can explore the complex relationship between the customers, events, and products. So we can start to ask questions. Whenever a new event arrives, such as a new purchase event or bounce event, a query will be made and result will be returned instantly. This graph illustrates how the query works. First of all, both Dylan and Alan purchased a product total travel care. And then Dylan purchased another product which is premium care that Alan doesn't have. And finally, a recommendation of premium care will be suggested by the system to Alan because both Alan and Dylan work for the same company and they have the similar demographics. Behind the scenes, the query is constructed by a simply gleaming query without any complex join required. Take the first one as an example. The query means customer C1 purchased product P1 and searches all other customers also purchased P1 as well as other products. For example, P2 then return those products that customer did not purchase. And then the second query is similar to the first one, but just return the results based on the port rating. And then the third one is just simply return all relationship of a particular customer. We just understood how the project journey works and how it achieved the objective. But why can't we do it with traditional RDB? Firstly, to cope with the rapid changing digital environment, especially for those services built on top of cloud computing. We need a technology that evolves quickly together. Graph database provides dynamic schema capability. Secondly, due to the complexity of the environment nowadays, the connected world, large amount of relationship can be changed and added. A lot of time, you may not know the questions when the data has been modeled. And thirdly, for some scenario that involves multiple degrees of separation, relational database takes long time to return the result due to the table join, and then the query could be very complex and difficult to maintain as well. Graph database gives a iterative way to make a query. And fourthly, you pretty much want a constant response time that is especially important in real-time processing. Graph database will do a much better job than the traditional relational database. Here shows the case study with performance. The case study takes flight data from an airline and model the flight routes based on the flight data. And we came up some queries to retrieve all possible routes from source airport to the destination airport. Then we compare the response time. And the performance benchmarking shows that the graph database is much faster than the relational database, which is MySQL. And it also gives a much more consistent performance for the queries in terms of the number of hops. Besides, the TIBCO graph database outperformed the other popular graph databases that are available in the market in terms of both response time and CPU usage. This graph shows the consistent performance of different number of hops. You can observe from this graph that the relational database cannot really handle the job when number of hops beyond 3. Again, TIBCO graph database has the best performance in terms of the performance consistency. The session is ended here, and here is some takeaways. We learned that graph technology is the next major evolutionary step to enhance data and analytics, and it is the core technology of the project journey. And we also learned what it is project journey and how the project journey fits into the real world use case and also how it works. And then we learned how the recommendation works behind the scenes using graph technology. And last, the performance comparison between the relational database and also the graph database. Thank you for joining us today. Bye.